Chandelier's pretty impressive.
We're streaming here, so but yeah, you're.
It's thinking, it's just I fucked it up.
Is this one of the classic ones that weighs like 500 pounds?
I don't know.
Probably.
It's not coming out. That means I missed the show function.
What's going on? Also, what's this automatic suspend? Suspending soon because of inactivity. Not active.
Wiggle your mouse like it's a job.
You can be more active.
Wiggle around a bit, it'll be fine.
There's a slide for that.
That's a lot. Oops.
It's not so fancy to go this way.
Oh.
Here it comes.
The expression on your face.
Wow, that's cool. They should light it up a speaker.
Blind him in the process.
Oh,
Made it flash. Also made music with physical. Oh yeah, that one. I'll go back.
Multicolor one.
Yeah.
Ooh, yeah.
Especially if you can make it spin.
Oh yeah.
I still think they'll put the spiral one up there.
Really gone mad with power. Who knew your presentation would have dancing comments?
Do you have any chairs left or just a start? Chairs are taken.
Yeah, sure.
I'm trying to figure out the cue for when to start. Everybody get a drink ticket or two?
We did not know. Oh.
This is a different style of pizza, so. I'll survive.
Yeah, that's great.
Yeah, just go to the bar.
Nice.
I know, but what is that? I think that is that thing. They're out of the city. Tacos are actually good. Who's going to PyCon?
I'm not sure this year.
Let's have trouble getting their company to pay for it this year.
He didn't bother to ask because I'm not working while I'm at PyCon.
you go last year?
I did not.
Okay. I don't remember seeing.
There's also, if you somehow can't swing that, North Bay PyCon in Petaluma.
Oh, yeah, you just watched that.
North Bay Python. Where's Petaluma?
North Bay.
North Bay, yeah.
San Francisco Bay.
It is about
Oh,
an hour out from San Francisco. So cross the San Francisco Bridge and head into wine country.
ah.
Fun fact, remember the 195 hills?
Yeah. I know it was in that area.
Yeah. So, except now they caught fire. Slightly darker shade of.
That'd make an interesting Windows desktop.
Yes.
What is this?
Typically the third one is a very quaint little like one track, one room. Calling it tracks is a stretch, right? 5 or 6 talks each day. Nice spots, small groups. I'm told by video production, it will be a more stable.
Oh. If you're interested in other tech events in Chicago, I know there's like a one-day Postgres conference coming up.
What Postgres, right?
Is that?
When is it? 15. Of this month or of next month?
They would be busy.
Oh, neat. He lost some power. Right?
Yes. Yeah, last time.
Any objections to get started?
Sure.
We have more drink tickets?
Yes. Who needs drink tickets?
Ready?
Sure.
Thumbs up. All right. Get started. Chatter going on here. We gotta wait for them to finish. Welcome to ChiPy's main meeting, February 9th, here at Kitchen 17.
Thunder Maid.
Noted. Corrected. All right. That button didn't do anything. Hey, that button did stuff. We have a code of conduct. Be nice to each other. Look at our website. In case you don't know what be nice means. And if you have any trouble, talk to the board. We'll get to that in a moment. You want to sponsor us? Get your name up here. Company's name up here. That's great. And you can buy us pizza. That's also great. What's this group all about? If you're new here, we do Python. We've been doing Python for a long time. Board members, these are the people who make this thing happen. Without them, it kind of wouldn't happen. Whoever's here, just raise your hand. Yes, indeed. Got a code of conduct problem? Hit one of them up and they'll help you.
You sound better.
Sorry. Oh. All right. In addition to this meeting, some other things go on. I think it's safe to say they go on. How much detail should I go in about this? Can I say something about this?
AlgoSig is very active, so
We hosted the AgroSig at ChiPy at Tegas last week, where I work. It went great.
All right.
Looking forward to hosting them again in the future.
And if you, the buddy mentorship program is a project that's run on our website, that's active, as active as you make it. This project allows you to say what you want to learn and what you're willing to teach, and we have an application that will match you with someone who can teach you the thing you want to learn, or who wants to learn the thing you can teach. And also we have the job board, so if you're looking for a job, or if you're looking to hire a programmer, we welcome you posting to our job board.
And also, if you're interested in like hosting a SIG or creating your own SIG, feel free. Let us know. And if you want
This is more in action, making things happen.
Yeah.
Yeah. And, we have social networking things. Tonight, we have talks. Josh Orner, by the way, if you want to give a talk, especially people out there in internet land, come down here and give a talk. Dr. Joshua, he's our new talk wrangler. Hey, Fisherman. Hooray for that. And PyScript, Python and web browser. This is what I think it is. Something hit my something or other a few months ago. It's like, that's cool. All right. Anything else? No, that's it. Looks like Joshua's first. Oops, sorry about that. Steps over here.
to make sure to speak up. It's a little loud. It's a little echoey in here, so just make sure you project.
Yeah, I noticed that it was actually making my demo.
Well, that's a mic. That's for the internet, not.
Yeah, we don't have a mic for the room.
Right. Well, is this?
Well,
But it
For the
won't, there's no. PA
Oh no,
system.
no PA.
There is a PA system, we just didn't dial it in.
there is.
That would require wiring.
Source found. I can try hitting the source button on here.
Yeah, I think that's what we did earlier.
Okay, source.
Yeah.
Jack mind that, and so we can figure out if it's one or two. No, it's not. Well, there's only two inputs.
Two. Yeah, it's two. Should be two.
Searching. There we go. Okay, so yeah, that's.
Is that a Windows, Linux, Mac? Maybe you have to extend the desktop. On here.
Yeah.
So can you hand me my bag?
Oh, Mac. This is taking me back to a number of conferences. I finally got a mini display board on there, which works better.
No.
What do you know?
It doesn't?
How about USB-C?
Yeah, I'm getting on my deck.
Yeah. For some reason, the Mac HDMI port.
That's why it takes an hour for my.
Yeah.
It might behave more on that source.
And so,
Or maybe it's like HDMI.
This projector HDMI 2 sometimes glitches out. So here's the HDMI 1.4 might be better. Stand by a second.
yeah. I do think they're doing it's just, and then, Canvas, you know, first time I got introduced to them, oh, this is really cool. You know, and, just, manipulating very good, we get through a lot of stuff.
Yeah.
Because I figure out how to, the common use of different things.
Source sound.
Specific.
Hey.
Specific ones, and duplicate and stuff. It's been pretty fun. Now just, you know, checking it out. It's just
Hello, here we're going over making a chatbot using Hugging Face. I am a police manager with Bank of America. I'm also the new speaking wrangler. I also do recreational natural language processing. So this is my fun time. So just a simple breakdown of what we'll talk about. Like natural language based design using the transformers library to judge consent and react accordingly, and speech recognition and speech library. I would say this is relatively easy. This is like we up on like to how somebody else did it. This is intermediate. This is a rough design of speech-based interface. So we could start for a listen for wake word. You could also say maybe continue a context, especially with or start from nothing, which is the newer and hotter like ChatGPT uses. But then the next is like you acknowledge the user, you enter, depending on how it is, and then just response. But when you not port, which can be skipped. Obviously, then we just interpret the request using your model, run the interpret task, and first you want to, for the words you want to stop interaction, anything to say stop, writing a stop word, you read the output as changing state. Some models are stateless, others not, or others maintain some state between interaction. In our demo, I've simplified it to not have a wake word, but taking a wake word could be as easy as using an if conditional, and then just continually looping for the audio. Like we start with the event loop. All loops that are event loops are mostly a while true. Or they're really like the infinite loop, which is also can be seen from embedded devices. A lot of embedded devices are just waiting for some kind of input. Once they get that input, then they interpret it. You have like the sleep time sleep. You wait. It's like you don't want to do this so continuously that you either run out of resources or you have problems like that. So we take the input and give a command that's granting the speech recognition. Line 3 is just the debug function. Then you take the input and do lowercase. That's the simple processing that is done. In more complicated systems, probably that line can be vastly more interesting for you to implement. But this is a simple system, and then This is to stop the interactions. So goodbye or bye. And then talking, bye, have a good day, and else it'll just output the response. Also, the loop that's missing, like judging the sentiment, and we'll output a talk that'll be demo. So here's the thing, I use somebody else's model called BlenderBot on Facebook. So Hugging Face is an emoji. There's also a website, huggingface.co. Pretty great idea in natural language processing to look at emojis since everything else has been registered on the web. So this is a distillation of BlenderBot, meaning it's a lower parameter model. So models have parameters. Those that determines like how the model interprets things after training. So we can generally assume that broad definition of machine learning is a program that learns based upon input and gives a functional approximation of a desired output. Well, some things may or may not. So it's not, so it has a like a heuristical, not like a fully algorithm. If it could be solved by an algorithm, we wouldn't use that, so it's the wrong tool to do the job. There is a BlenderBot with 9 billion parameters, and I've heard that a good large language model or managed model in general are a ratio of 1 token to 20 parameters, meaning 1 token is 1 word, or whatever counts as a word. Such as in English, a word would be apple. In Python, a word would be a statement like break, a text input, or text, or various other valid things in the system. And in Chinese would be like a pictogram. But you just map those into numbers in a dictionary. Then this is the blended skill task, but they call them my BlenderBot. There's 9.4 billion tokens. They put that into perspective. That's around the level of a previous GPTs, or the GPT-3 was in the hundreds of billions of parameters. And this is like the input and output. Also, this system has gone under multiple revisions. There was BlenderBot 2.0, which actually can do Google searches and has much more memory, like context. And BlenderBot 3, they've since refined this. BlenderBot is, now when you use the GPT, what I've noticed when people use the GPT-2 system, and those are actually targeting toward prose, or basically books. Then people will answer for more as far as the input and output, because they judge that, well, I'm just typing a conversation. That's not the right model to do it, but it probably did it just as good because in prose there are conversations. Or it could be just the high, we call these large generative models just can fool people anyways. So I wouldn't assume sentience in any of these systems. So this is how easy it is to just take one of these large language models and then put it into Python. It's even less than our event loop. So it just takes the so tokenizer, like I said, the tokenizer takes out the it's called, first in the function signature is utterance. Utterance is basically input text. Take the input text. All this is basically boilerplate. It's actually on the website I was showing you before, but it tokenizes the inputs, takes the inputs, feeds it to the model, generate the reply IDs, takes the responses of that, iterates of that, and then it'll rank them. And what I do is I just take the first response. This is also an even simpler one with the sentiment analysis I was talking about before, where they have a hard-coded pipeline. This is hard-coded to be used. This distilled model that was distilled BERT. So BERT was a fairly larger model that Google made and was probably one of the more earlier transform-based models. But what Hugging Face start was distilling models or making them smaller, but keeping their characteristics of being useful or high accuracy to compare with like the original system. So if you're familiar with deep learning, you think of it as a sort of dropout, which does a similar thing, but it's not. It was a much more publicized thing. They also did it across a number of models. So now we're going to how to recognize speech. Recogniting the speech is pretty hard. I was having an issue in this room because I tested it in my home office, which is relatively not that noisy, but this place has, I guess, I can hear the reverb. I heard people shuffling around, so there is a calibration system that I just figured out. I hopefully make the live demo work, but I also have to do in these reports. So I just created an input string, initialize a recognizer, and then you tell it to read from the microphone, listens, pause this all for 1 second, so it's like we'll listen for like 1 second and then stop, and then we'll pause until the next input, and we'll take the audio and listen for the source. And then this will be inputting it using the Google API for speech recognition. So the speech recognition, this is all the speech recognition package. That's the recognize Google has an open API key, I guess, for testing purposes. Use that. You can change it up. I can change mine up to Whisper from OpenAI. It's a whole different thing, but it doesn't matter. It outputs dictionary and so forth, and then I just extract stuff from the input. Well, it shows you the input, and then I extract stuff. And then how to deform text to speech was really simple. 4 lines of code. It has a text to speech engine to just say stuff and wait for the next input. It'll run and wait. Because it's sort of asynchronous. Because when it's talking, the main Python will have to wait until what it has to say is done. Yeah. So start the demo. Hello, how are you? Hello, how are you?
You sound positive. Yay. What do you like to do in your free time?
Do machine learning models and text and chat bots.
You sound positive. Yay. I love texting and chatting. It's so much better than talking on the phone.
I don't really like to do that. Yeah, I don't really like to do that anymore.
You sound negative. I don't like it either, but I can't help it. I just can't stop thinking about it.
They're never gonna give you up, they're gonna let you down.
You sound positive. Yay. I don't think I will ever be able to do it again. I was so scared.
Anybody want to say, tell me to say something?
You sound positive. Yay. I'm not sure what you want to say, but I hope you have a good day.
Listen.
How do I know you're not ChatGPT? Will you tell me everything you know about toilet monsters?
You sound negative. I don't know much about them, but I do know that they are evil creatures.
Then obviously the last thing. Goodbye.
Bye. Have a great day.
Yeah, I'm gonna have a guest that I'll update with better code. I would like to thank our hosts to teach me more about the language and the library.
So which of those are open source, or are they all, or like, which of those components are open source, or are they all open source?
Okay, so that's a more different question. So half of them, some of them are cloud services and some of them are local. And so
I see.
say the cloud services aren't, well, maybe they are. So you just go into the speech recognition tab. It's really a wrap.
So in the text to speech, I couldn't quite tell what package that was. Of like
PyTX X3.
Okay.
It invokes that invokes the Windows, Linux that actually has text to speech copies in Mac OS's native system.
Hmm.
You could use like Tacotron or something to be better. That's just
I saw that there's an event loop for processing the response. If I wanted to either, like if I had a corporate wiki and I wanted to include that in my response, would it be difficult to integrate that? Or if I wanted to ask like, hey chatbot, is Jenkins mad at me? Could I use the event loop to inject domain-specific knowledge?
yeah. I mean, I could have actually added ChatGPT. Like the loop, if we go back, I mean, your event loop is your event loop, so it's just conditional. It's very simple, like while.
Okay, I was just, because you consult the cloud service to get the detailed response, so I wasn't sure how flexible that was.
Well, and, actually, well, I mean, the cloud service would have the time, should have the timeout. But you don't need to, you could use like a local one, like OpenAI Whisper or CMU Sphinx. It's just look at you could do that.
Okay, thank you very much.
Have you done some comparisons of Whisper with the Google one? Just curious.
Well, I was having trouble with Google, so then I installed Whisper.
Is that what you're using there?
I think it was Whisper to recognize it. Yeah, the same thing beforehand. It must have been very sure it was the difference in audio. This room to my home office. So it had what wasn't shown anywhere was a calibrating function. That's part of speech recognition. Where once I started the script, since nobody was talking, it was was reading the audio from the room. And then once it read the audio from the room, it tracked that for the recognition.
Any other questions? Thanks a lot.
That was fun. All right, we're gonna take a 15-minute break. There's probably more pizza back there. Save some for me this time. And then we'll have another talk.
There's no thing for that.
Are you putting it into reports or are you? No, are you doing it for just a spreadsheet or? Yeah. Okay, so it's always,
I read it for that.
Sorry. I'll stop. Every month I have some hardware that can show off. This one is a silicon wafer. Get away from the pizza and come look at this. This is the result of my the wafers.
It's like, so what's on them? Were they weren't?
So there are.
Yes.
So one, yes. There's a die. This big. It's some sort of like plastic. So there's like 30 slides.
Yeah.
Like I always wondered. So they grow some.
We can't rely on the silicon.
Right, well, because they're more of like.
Yeah.
Yeah, there's a name for it. They like they possibly columns. When they slice it.
Okay, okay, wow. Why is it? It's just
I'll do that.
a lot of
So
Bumpy. See, I was someplace in IT department. And then we were working with another company. And I remember that technically, actually, to deal with it, you know, stuff that they're supposed to, I'm like, okay, this isn't working. This is something you can do. And they're upset about it. I'm like, I didn't make it. I'm like, this is actually your work. Your job.
I don't know where to start.
Yeah.
It's all process, all balls. You don't even know what's right. Like, it's still weird words. It's like you don't know what to start. There's no like this.
Yeah, and having, you know, not enough time. It's still information you're probably very good. But that's still different than being rude.
Yeah.
Or saying, you know, okay, I've got like certain things before you, I will get to you can't even say that. Versus, yeah, well, did you turn it on? Yeah, stuff like that. You know, it's like, well, gosh, yeah, I guess I haven't worked with spirit in a while, so I think I do know how to turn it on.
Where, what step was that screwed up?
Yeah, well, because, if you
But the reels would drop from like 98 to 97. They drop from like 80%. Yeah.
I heard one of the reasons things happen because you can't
And the semiconductor. And you think, well, what they do last one? Because they do like,
Yeah, yes, exactly, yeah. Don't start from me.
that's how I
Well, here's the person who starts already with R, go to R. You know, write yourself a program that says, okay, this person works in any career, go to R. You know, so you have smart people. You know, work at uni. You know, that's it. Oh, I'm trying to avoid going to the ICE for help. That would be like telling the doctor saying, don't come to me for help. Okay, then you're the wrong doctor. Yeah. Right. So it's not index. Yeah.
If I'm looking at the database, I will figure out I need to that process.
What is it consist of? Where the data comes from? Yeah. Yeah, so it's going to not knowing which module you know, or yeah, right, or good luck. So with that, there's more than one.
Yeah, and it's more of like they just need to like one single person to. I understand that this is a documenting like one there's always a distinction between IT and business.
Yeah.
This totally my role is that's my role.
Right, you're just trying to communicate what's in this thing over to this thing. Well, it's
Sacrificial person.
What's in a database, and they give you the answer. Yeah. Yeah. Yeah, I think we should make a little.
Necklace.
And then make a little so that it like it doesn't sit on your chest.
Maybe there needs to be an amplifier for it. Maybe there needs to be amplified somehow. Or maybe I need to adjust the volume on here somehow. See if I can.
No. You know what it was? I think.
Oh, here. Oh, you'll record bubble. I can bump it up a little bit.
Yeah, so that.
I'm still working on it. Like the cars driving in the background. I like the cars driving in the background. Makes it look real happening.
we didn't have a proper like proper
You'll get people back in.
Sure. Yeah, 3 minutes.
Talk's gonna start.
All right, thank you.
Set a reminder for 3 minutes. Keep talking.
But right now, how do I fix that? And I'm like, I know the answer. Come on.
Yeah, and then first thing it's just easier for me to just run it here. Yeah, oh, okay. Have you tried it?
Enough. All right. Our next talk.
Oh, fair enough. Hello. Oh, that's nice. Hi. I'm gonna try and be loud for the people in the back and the people in the video, and if I forget that, people in the back, you can be loud at me and more reciprocating. That'll be great. I'm Jeff Glass. I'm one of the devs on PyScript. I'm gonna talk to you tonight about what the heck it is and what you might want to do with it. The slides, for those who are following along at home or later, are on my website, jeff.glass/chippy23. So if you're in the back and you can't read them, or on video and you can't read them, but you're watching this in the future, they're all there. None of those social media places you can find me. I'm Jeff Glass. If you search Jeff Glass Python, I tend to pop up. There's a Jeff Glass hockey player who squashes my door looks like anything else, but I'll get over it. All right, so PyScript. We're going to talk about what is it? Why would you want to use it? We're going to talk a little bit about how it works and the stack that underlies it, just for some context. We're going to talk about how you use it if you want to use it after that. And then because I know this is a group of sort of self-selected nerds, because otherwise why would we be here tonight? We're going to talk about like why I like working on it. Like why is it interesting and hard and challenging? What's the weird stuff? There will be some live demos if they work. If not, there'll be some images of live demos. Okay, so what is PyScript? If you've ever worked in HTML, you know you can add a script tag to a web page, and inside that script tag, you can write JavaScript that runs on your page. PyScript is a project that lets you do the same thing with Python. So on the right side of the screen, there's a snippet of an HTML document, and you'll see the PyScript tag, and inside it is just plain old boring Python that will run in your web browser when you put this in your page. That's the gist of what it is. It adds a script tag that runs Python to any HTML page. There's some other parts of the project as well. There's some extensions to sort of the browser API. We have things like display is an added built-in we put in to do other things. We'll talk about that in a bit. You have the PyClick attribute of this button. If you've written JavaScript before, you use the onClick attribute to run a JavaScript function. We have a PyClick attribute to run a Python function. So we're doing webbish things, but with Python instead of JavaScript. And it's an all-in open source project. So it was sort of spearheaded by Anaconda, launched publicly as one of the keynotes at PyCon last year, where I saw it and got really excited about it. And I was like, hi, can I contribute? And now I'm one of the sort of core devs on it on the open source side. So I'm not an Anaconda employee. I just think it's really neat and has lots of interesting challenges. So let's kick off with a demo. And I guess we'll learn right up front how well the demos work. Hold this up here. Of course, we'll make that a little bit bigger. And we'll close our terminal, close our things. Font size-wise, people in the back, how is that on the code side? Can you see it? Yeah? Awesome. So if we scroll, that's an advanced demo. Let's go back to the Hello World demo. So the code on the right side of the screen here is what is being displayed on the left side. So we have a PyScript tag that's running display is meant for nice display. Print, this is printed. And adds also a PyREPL tag to the page you see down below. And that REPL really is a REPL that runs entirely within the browser. And we'll talk about the architecture of this in a little bit. There is no server, so to speak, running the Python. The CPython interpreter is shipped to my browser window and is running there. So if I were to put this demo live on the website instead of at localhost, and you were to load it, and actually if you go to my blog, there are some live examples there, you can run CPython in your browser window. Cool, right? So that's the gist of Python, and that's what we're talking about tonight. Let's get ahead here. All right, so before we talk about how you use it, let's talk about why you might want to use it. I mean, you can tell I'm excited about it just sort of a priori, right? I think it's cool. But why might you want to run Python in the browser? And for me, this kind of exists on a spectrum, right? On one end is like web stuff. Like stuff we can already do in JavaScript, but some of us don't know JavaScript. And some people don't know JavaScript, and Python has this sort of goal of being accessible, right? It's sort of a first programming language for a lot of people. So you could use Python instead of JavaScript to do stuff. You could make websites, you could respond to forms, you could submit queries, you could fetch things from APIs, things like that, all without having to learn JavaScript. You could reinvent all of React in Python if you wanted to, and you had a lot of time. Right, exactly. React is already React. But you could. That doesn't, or make it better, right? Or do your own thing, or cut out some of the cruft from an earlier group. The other end of the spectrum, in my mind, and this is just something that I have made up, but in the other end of the spectrum, in my mind, is things you would already do in Python. Let's do them in the browser. Right, so as I mentioned, TypeScript requires no install on the user side besides opening a web page. Right, so if you want someone to be able to run your little bit of code, and maybe they have no idea how to install Python, or install from a pip file, or start a virtual environment, or all the things that need to happen to run a piece of Python code, now you can have them run it in their browser, and we all know how to use pages in the browser. Another example that I'm excited about seeing is doing live examples in web documentation. Right, so you might go to like a read the docs site for a project, and you look at a piece of API and say, it'd be really cool if I could play with this, and click on a open this function in a REPL right here. Then the user can execute that function in the browser window and sort of see in real time what changes to the output do. And read the docs, of course, is a static site. It's built as a static site. Because PyScript is running in the browser and there's no server backing it, you don't need any additional infrastructure. Other use cases, doing data analytics-y things with sort of big data, where if your end users have a gigabyte of data they want to process, and your Python code is like, with NumPy, with pandas, with everything is like 50 megabytes. It's a little silly, I think, to have them ship a gigabyte to your server, do the processing, and then send the results back. Better to ship a 50 megabyte runtime to the user's browser and have them just upload it locally and run Python there. So that's like sort of a networking version thing you might do with it. And then like on a personal nerdy note, I did my advent of code this year in PyScript. I don't know how many of y'all did advent of code. We did some advent of code. Yes, definitely. Yes, I saw some activity there. So I did advent of code. I got to about day 15. I didn't finish it all, I'll be honest. But so I did it in Python, solved the problems, and then moved it over into a PyScript page. So on my blog, as I'm posting day by day, if you want, you can go and copy and paste your input for the day and run that Python code that you'll see sort of displayed below here in the browser, right? And sort of validate your answer if you wanted to. I don't think anyone actually does, but you could, is the idea. And because this is running in a browser, right, we don't have to limit ourselves to just sort of textual output. Right, so for those who didn't do advent of code this year, this day's problem was about finding the common character between two halves of a string, and then depending which character it is, that's a score, and you do that for 1,000 lines and total up your score in any case. So on here, right, we have this was my answer for the day, it was 8298, it was right, it was awesome. But as long as we're sort of doing things in the browser, why don't we do some rich display stuff as well? Why don't we style our output with CSS or JavaScript or any of the other rich display options that we already have in the browser? We don't need to be sort of limited to terminal-ish things. And this is sort of the middle of this spectrum that I think is really cool, is we can run Python in the web. We're not just doing sort of web-ish stuff. We're not just like running our Python in a new place. We're doing stuff that we can only do when we're running Python in the browser, right? So we're having outputs to advent of code problems that run with rich outputs, right? Or doing stuff in real time. We can also utilize existing JavaScript display libraries. It's a really nifty functionality where basically you can hook into any existing JavaScript code from TypeScript and vice versa. So if you've ever seen like a cool JavaScript animation library, and you're like, well, dang, that's cool. I wish we could do that in Python. Now you can't. We'll just look at that a little bit later. And again, doing things sort of with zero install capability on the user's end is fun. So here's a cool example. This is straight from our Discord, which is our community hub. We had a teacher come through, like a high school teacher. He said, I have this problem, but I'm not a coder. I'm going to try and solve it. He said, in our district, whenever we have to take a course, the district makes us deliver a paper certificate to prove we took the course. And nobody in 2023 is delivering paper certificates. So how are we going to solve this problem? They said, I'm not a developer, but I know good Python. And I know I can do some image manipulation with Pillow. I can output a PDF, various things. And so what he did was made a little website. You go, you type in your name, you type in the class you took, how many hours it was, and it lets you download a PDF of your thing on the honor system, right? And this is like not a problem you couldn't have solved before PyScript, right? There's lots of ways to skin this cat. But what this was is a really cool collision of somebody who said, you know, it was easy for me to write because it's Python. Python's pretty easy to learn. And it was easy for my users to interact with because it's a website. We all know how to use websites. I think that's a really cool space for us to live in. On the sort of more sort of advanced visualization end, I have another live demo. So let's see here. Let's make sure this really is live. There we go. So many of our favorite libraries run natively in the browser. This is a graph of some fun mathematics that, I'll be honest, I did not write. For Matplotlib running live in the browser there. And because it's running live, we can adjust the parameters of our visualizations in response to user inputs, right? So as I change the number of radii in this radial graph, we can have the data respond to that in real time, right? So it's not just that we're like doing things with Python and shipping images over. We're actually running the code in the browser and respond to that, right? Which is kind of, let's see here. This will start moving again. It's not that. Now we'll start moving again. We'll figure that out. Oh, I've talked to you for like 15 minutes and quite a clip. Questions before we go on? Yes, sir.
Do you recommend some type of database to use with this system? Maybe the obvious one is SQLite.
SQLite would be good. The trick with using, so the question was for those in video and those in the back, would you recommend using a database in particular for this? What you will probably find is because most database access is synchronous and most web communication is async, that having a proxy layer that actually does live on a server somewhere makes things significantly easier. You can do SQL writes if you have an HTTP server in front of your database on the remote end, and you can just make requests to it. But natively accessing it is tricky.
Okay.
That's what makes sense.
Yeah.
We got a question. Oh, sir.
You mentioned ChiPy,
Yeah.
but how? What?
How? For sure. That's the next section. You're actually one slide ahead of me. That's a fair question. Was there a question? Yes, sir.
Could you compare to iodine?
You're 2 slides ahead of me. And you got a question, sir. You're 6 slides ahead of me. Totally fair. No, this is great. This is all the questions I would ask too. Is like how, what, how, why, what? Yeah.
Actually, I can form this in front of you. So like, part of the reason you asked about MySQL or SQLite is the web storage API the browsers have is just an implementation of SQLite. That's deprecated. We live in the worst timeline. But like, so how well is this Pi script integrated with browser functionality? If I wanted to use their key value store for cookies, could I do that easily? Or if I wanted to have a web worker, could I do a Python web worker?
You sure can. You can do a Python web worker or service worker, and we'll talk for those. We'll talk about the distinction in a little bit. The question, I should say, for the video again: how well does this integrate with like the features the browser has? The short answer is PyScript isn't emulating JavaScript features; it's hooking into JavaScript in the browser itself. So if it's an object that exists in the global scope in the window, PyScript can call it. So if you have an API like the web serial API, right, or cookies or local storage or something like that, you can access it from PyScript because it exists in JavaScript. Yeah.
Sorry,
Please.
So think of things like this, and I'm looking at what that like we
what the future of development is with like with IDEs and Python, etc. For sure, yeah. So the question was like, what is the future of like languages living in the web browser? Essentially, like what does the future of development look like there? Boy, your guess is as good as mine. There's more and more stuff coming to the web, right? Like the bit is the web is the world's most popular operating system, right? Which is kind of true, right? It's a UI that people get, and so we're only going to be seeing more and more, runtimes that run things other than JavaScript in the browser. In fact, that's going to be a good segue, I think, to some of like our some of our things that underlie PyScript and work well across languages. right? So this is like the technical like underpinnings of PyScript. There's not a quiz, it's 3 slides, but there's some like vocab in here that we need to know to like explain how PyScript works and some of its limitations. First thing to know, WebAssembly is essentially a variant of assembly that runs in a virtual machine, a virtual static machine in any modern browser. Right? This will work in Chrome or Chromium or Firefox or Safari or Opera or Edge or what have you. There's a textual representation of it here. It's just an assembly language. It's another target that your compiler can target, like x86 assembly or ARM assembly or something like that. Just know it's like an assembly language that runs in your browser. I hardly ever think about WebAssembly when I'm writing in PyScript, the same way I don't think about x86 assembly when I'm writing in Python. But later in the talk, when I say you can't do X because WebAssembly doesn't let you, that's that word. So we have this assembly language that can run in the browser in the same way that your assembly can run on your CPU. Then we have a tool chain to compile things to WebAssembly. The Emscripten, it's a tool chain, I don't know what the right term is. Essentially, it's a tool chain that allows you to compile C and C++ programs to WebAssembly. It's based around Clang and LLVM, those who are C and C++ in the audience. Basically compiles your C code to another variant of assembly. This one happens to run in the browser. One thing it also does, because many bits of C and C++ code that are meant for sort of POSIX-y systems assume there is a file system present when they are running, which is not necessarily true in sort of the naked environment of a browser. Emscripten wraps your C++ program in basically a shim that says, if you write to standard out, I will be able to do something with it. If you try and read a file, I will create a virtual file system that lives in memory for the purposes of your program not throwing up its hands and saying, I don't know how to read a file. Right? So we have this virtual in-memory file system that sort of comes into being whenever we want one of these programs that's compiled in this way. Right, one more concept. So someone asked you asked earlier, right? CPython in browser, what and why? The Pyodide project, which was another question, is basically a project that takes the CPython interpreter and does some of the hard work of getting it to compile into WebAssembly, where it can then run in a browser. There's a couple other parts of the project too. The magic of how Python and JS hook together is managed by the Pyodide team in a really cool way. And they also do some package distribution, right? So if you think about your favorite like numerical processing library like NumPy, a lot of it is written in C, right? Or maybe these days Rust. It's a little beyond me, right? But we have a Python interpreter. We don't have a C runtime in the browser. So we need to basically pre-compile those parts of popular libraries to WebAssembly so they run in the browser. Pyodide does that for 150 packages. All the big ones, Matplotlib, NumPy, Pandas, Polars, all that stuff. So this is roughly our stack, right? We basically, Pyodide team compiles CPython to WebAssembly where it can run on the browser. PyScript sits on top of that and it adds a functionality layer to the Pyodide runtime or other interpreters. This is a very active area right now. We're integrating MicroPython into PyScript, which is not as full featured, but very much smaller, right? So if your target is like, phones with limited connectivity, for example, the difference between a 2.5 megabyte zip and a 20 kilobyte zip for MicroPython is huge, right? So, but you have to acknowledge the trade-offs between obviously CPython and MicroPython. All right, that was only 3 slides. I'm going to pause for questions again. Questions in the back there.
You may have just answered.
Yeah.
But is the 2.5 megabytes the full file size it takes to serve all the necessities of CPython?
So the Pyodide runtime is about 2.5 megabytes. PyScript adds a little overhead on top of that and try and keep it small. What is the most expensive, to be honest, is the additional packages. If you download the flag for like the standard scientific packages, which I think is like NumPy, scikit-learn, maybe Matplotlib, and a couple more things, that's like 50 megabytes right there, right? So that's where it starts to get expensive. For sure. Yeah.
Maybe you've got a slide on this, but like what packages are available, or do you have a lot of packages, or is it just like those 50 ones that Pyodide supports?
Yeah. So I will touch on this later, but this is a really good question, like what packages actually can you install and work? So the things you can install into PyScript or using the Pyodide runtime are, there's like 150 packages that pre-compile, right? Anything that has a weird C extension. You can also pre-compile, you can also import anything that is on PyPI that is a pure Python package,
cool.
Right? So if it just uses Python via the CPython interpreter, you can run it. There are some exceptions in the standard library that we'll get to later threading and multiprocessing are constrained by the limits of the browser. But pretty much anything in pure Python just runs. Yeah.
What kind of sandboxing do you have in terms of,
Not busting out.
yeah,
Yeah. So the question is, what kind of sandboxing is available? This is one of the cool parts about the WebAssembly infrastructure. When you compile something to WebAssembly, whether you're targeting the browser or an offline WebAssembly runtime, the compiled object itself actually has essentially 0 permissions. You have to define every external permission. They call it importing. In my mind, it's an export, but the terminology is import. So you will, in your compilation process, you define the input points that you want to give it. Like, for example, write to a file, write to JavaScript, write to the screen. They sort of map to POSIX syscalls. You say, okay, well, if my C program calls this POSIX syscall, run this function I've written. And if you don't provide a function, it can't call that. So it's essentially a fully sandbox environment, assuming that like Chrome and things like that can let their runtime. Yeah, it's pretty neat. Yeah.
So can I like access like stuff like the web GPU, or just have to find those used like for?
Yeah, you can access things like web GPU. You can access things like Chrome just came out with like a native file access API. If you have a website that's serving Chrome, you can ask the user for raw access to a folder on their hard drive, which is a little wild. But also, if you've got a gigabyte sitting on your hard drive and you want to do some processing in your website with it, and this is not PyScript specific. This is just in the browser. You can say, give me raw access to that data as a buffer instead of move it over into the memory of the browser and then process it, I think is the goal. But yeah, all of that stuff that exists in the JavaScript side is available via PyScript as well. All right, 2 more. Yeah.
You mentioned the precompiled packages. What if I have a package on ChiPy that is actually a wrapper for a C?
Yeah, so the question was, if we have a package on PyPI that's got C extension to it, essentially, right? Where it's a thin wrapper around C.
Yeah.
Yeah. So there's a couple things you could do. The PyPI team actually just separated their build step into a separate module to sort of make it more usable. The first thing I would try is basically running your package against the PyPI build process and building a wheel locally, which works pretty well. You can also include that into something like PyScript or PyPI. If you're using multi-threading or multi-processing, it's likely to fail. But there are compilation options for you to basically build your own wheel out of packages, if that makes sense. Yeah. One over here.
Give me good examples of any of the MicroPython stuff that's happening right now. Or tell me to Google it.
Yeah, for sure. No, I will definitely. Here, I'll tell you what. Let's.
Wait, can you back up? Oh, I got a question about the PyPy install stuff.
Yeah, for sure. And then we'll do a quick MicroPython demo.
You
Yeah.
said pip install something. When does that happen and where do you install it to? What?
Yeah, for sure. So the gist of it in a couple slides is that happens on page load, right? So the loading process is you load a little bit of JavaScript to get PyScript started. You load the CPython runtime via PyPI, and then whatever in your HTML you've configured to load, that downloads from PyPI direct. Wow. Okay. Or locally or some other URL if they want to, right? Yeah, it's pretty nifty. It's pretty nifty. MicroPython-wise, and I will do a demo, and I will brag on my colleague Nicholas, who was a big factor in the microbit, the sort of like BBC microcontroller that came out. Oh, well, if I don't have internet, it will be hard to do a live demo of that.
Kitchen 17, password, free Wi-Fi, all lowercase.
It's so good. All right, well, you watch me type password. Free Wi-Fi.
One word.
Do you want to be discoverable? I do not. There we go. First article there. And MicroPython technical preview. So like I said, so this is a technical preview, right? There's not full integration, partly because when we started building when I came on board, there's a lot of functionality in PyDide and a lot of the APIs is different from MicroPython, so it's not fully integrated yet. So let's do this better. But this is MicroPython running in the browser, right? So that's a hello world via MicroPython. This is back in 1.9.1. I'm not super up to date on my MicroPython versions, but I believe that's not quite current. But similarly, you have all the same syntax as CPython, right? You could have strings and all this stuff. What you don't have is the same You know, if you get it. Yeah, so the modules namespace is much less populated by default than it would be. Whereas in the Pyodide demo, let's see if Nicholas did this right for me. Yeah, so you see already we have a significantly longer startup time for loading CPython instead of MicroPython, but now we have all of our, not only our PyScript built-ins, which we'll talk about in a little bit, but all of our familiar built-ins if you run during a REPL, like annotations and built-ins and doctrines and such. So similar API. Does that sort of answer your question? I kind of just typed into a REPL. So, all right, let's talk about how you would actually write some of this if you wanted to. I know the top lines are small, it's because they're the links to the CDN, which you're not going to memorize anyway, or maybe you are, maybe that's fine. But I would say go to the slides or go to the GitHub page where they are in the first section and copy them there is the way to do it. Here's a real simple PyScript page. You have a head tag in your HTML, the stuff that doesn't show up on your page. You have a body tag, which is stuff that does show up on the page. Inside the head tag, you add a scripts tag that is pointing to the PyScript CDN. With the pointing to, I would say here, the latest version, which is 2022.12.1. A lot of the examples that we and everyone has published point you to /latest, right? So you always get the latest distribution. I'm here to encourage you, if you do that, then on release day, I will have broken your code. Pin your dependencies. Similarly, there's a little bit of CSS you can include from the CDN and just like style the PyScript tag in the REPL a little bit. You don't have to, but it's there for your convenience. And then you can just start writing Python inside the PyScript tag. Now, nothing is ever that simple. There are a couple of limitations that we'll come to, but that's essentially it. Just like the scripts tag you may have known from HTML, if your code, it's a little unwieldy to write like 300 lines of Python inside an HTML document. Not least because your IDE won't know that it's Python, and so you won't get linting or highlighting or IntelliSense or all the like things that we need to be programmers these days. So we have a source attribute. You put the source, you point it to another URL, then you can store your code in a .py file that your IDE is more than happy to do stuff with. So put your code in another file, you'll be happier for it. That display function that's come up a couple of times is really because Python's print function is meant for outputting to a file-like object, right? A stream of text that lives somewhere. And a web page is not a file-like object, really. I mean, it is in some sense that it's HTML, but it's not, right? It's a more rich document. And so we've added a built-in called display that takes an object and puts it in a specific place in the web page, specified by the ID of the div you're targeting. It also has some like rich rendering functionality. So here's some of that similar matplotlib code from earlier, and we don't actually have to ask it to render itself. We can just throw it into our display function, say, hey, render this plot, or render this image, or render this video, and it knows to wrap it into HTML and stick into the page for you. Just a little convenience thing. Yeah.
For packages that already have print statements or log statements in there, does that display break them? Or?
No, actually. So print, let's see, go back here to so if you just print something, like if you put it into a PyScript tag, print hello world, by default, it will show up in a display like this, what we call a PyTerminal, that's a textual output, or it will also show up in console.log by default. Those are both configurable. You can turn them on and off, right? Multiple consoles, but that's the default action. Mostly because we know that like a lot of libraries do use standard out. You can also wrap standard out with a plugin, which we'll touch on just briefly later.
You can turn off the REPL display too, or the terminal display too.
For sure, yeah. There's a configuration tag, which is the next couple slides, which there's some settings in there that say I don't want this terminal popping up anywhere. Or if you saw when we ran the Pyodide demo, there was that like loading spinner, like that pops up by default. If you don't want that on your page, the setting to turn that off or have your own spinner, things like that. We're in this really Python folks will appreciate. We're in this weird world, right? Where we want the defaults to be really approachable, and then we also want them to like not intrude on anybody's experience, right? We want print hello world to show up somewhere, so it looks like it worked. But also, this is like not a super enticing like end user product. So we're constantly like back and forth, like should the default be to like show something immediately that's ugly or not show anything at all? I don't know. This is another reason not to link to the latest version because we've gone back and forth a couple times. So if you update something, then you'll put that display tag. The REPL we were just mentioning, PyREPL tag adds a little REPL to your page. If you want to have just one cell forever, you just drop the REPL tag in. What a lot of people seem to want is a notebook-like experience, right, with the cells. If you add the auto-generate attribute, your REPL will generate a new cell when you already execute one, sort of what's happening here. I don't know, there's not that much to say about a REPL. It runs code, but it's in the browser. Configuration-wise, this goes back to your question about how do we install packages in this environment. And this is one thing I should make super, super clear. So Python, I think I've said 60 times, it runs in your browser window. It runs in the browser window, not on your computer, right? Not in the same way that like your CPython interpreter you installed from python.org runs on your computer. So like anything else running in the browser, it has no access to your file system or your virtual environments or your Python path, your environment variables at all. It's got nothing. In the same way that like Reddit doesn't have access to the files on your computer, TypeScript does not have access to the files on your computer, which is good. So when it loads, we need a way to like install some more stuff, to install packages, to reach out to PyPI, whatever we got to do. And that is what the PyConfig tag is for. Another tag you can add to your HTML. It does a bunch of stuff. One of the things it does is under this packages key is a list of packages to install from PyPI, or it defaults to the PyDI distribution, those precompiled ones, if they exist. If not, it'll fall back to PyPI. Or you can present it like a URL to a wheel file that you've compiled yourself if you're doing your own development. It's got some utilities. This fetch configuration here is a means of like it's basically a wrapper around the JavaScript fetch API, which gets stuff from a URL. And it brings the files that it downloads into that virtual file system you're talking about, right? Because Python, when it's running in CPython, doesn't know it's running in a browser. It's just trucking along being a little CPython interpreter. So when you do, with open file name as file handle, right, or print or something like that, it is happily reading and writing to the virtual file system that it's encapsulated in. Similarly, if you're going to import a module, it's acting within this virtual file system. So we have this fetch mechanism saying, hey, I'd like these files to exist in that virtual file system so I can use them. And that's what this fetch tag is for. It's super powerful. Honestly, I would go look at the docs. I help write them. They're okay. But ways to get things into that virtual file system so you can use them. We'll come back to this demo because there's other stuff in it. Other stuff PyConfig does, just to mention it, we actually have a plugin system, which is a way of basically allowing end users to modify the execution process of PyScript in the CPython runtime. If you wanted to have a piece of code that ran before and after every time a user executed a REPL, we have an easy way to do that, right? One of our goals for this is, if you're doing an educational thing, you say, hey, type into this REPL, a thing that prints to the screen. It makes it easy to say every time somebody executes that REPL cell, check if they've actually printed something to the screen, check if they did it in a really weird way with a code routine, all this stuff. The various hooks into that. And then ways to specify other runtimes, PyDI, MicroPython, and so on. All sort of wrapped up into one config tag. And again, this is just an HTML tag that you slap into your page, and when PyScript loads, it finds it, loads your packages, loads your files, loads plugins, runs your CPython code. Okay. Yeah, for sure.
The virtual file system running on the client side or the server side?
Client side. Yeah, everything's client side. So when PyDI, the PyDI or MicroPython runtime loads, what is loading is this WASM compiled version of that runtime. And when that initializes, it initializes this virtual file system every time on page load. So there's also questions around like data persistence, right? The same things we've had in JavaScript forever. How do you persist user data? There might be cookies, as somebody mentioned earlier. There's also newer techniques like local storage or IndexedDB or things like that you can persist local data to, but all of this is client side. Yeah. Other questions? All right. Don't be scared by the JavaScript on the screen. It's gonna be fun. So this is the and to be honest, so all this functionality in the next two slides comes straight out of the PyDI runtime. It's something that PyScript interacts with and is also working with them in. But I'm just bragging on my friends at PyDI. It's really cool. In the PyDI runtime, so in PyScript by default, if you import from JS, the module, what you are importing from is the JavaScript global namespace, right? So for those who are not super JavaScript, but I know it's a Python meetup, right? In the browser window, now that I have Wi-Fi, I can just do this. We'll open a console over here, and in that console, I could do this in PyScript. Maybe that's easier. Let's do that. So let's load up our hello world example again and delete it. And in the new PyScript tag, I'm going to say import JS, which is not a Python module. That's a proxy for the JavaScript global namespace. So now I can start using JavaScript functions and objects directly in my Python. So I could say js.console.log, js.window. See if this is actually live. There you go. Right, and now if I look down at the bottom, we have a bunch of like debug statements I have in Python commands. But now we'll see that not only have I accessed the console log from within Python, but it's actually logged a JavaScript object directly to the console. Right? This is the gist of the JavaScript Python interactivity, is that you can treat Python objects like JavaScript, and treat JavaScript objects like Python. How cool is that?
That's cool.
That's super cool. Here's like a more banal example that's been in the oven from earlier. Right? So again, I'm importing console and document. We're using the document object in JS to create a new element, styling it, and sticking it onto the body of the page. Right? So we have access to basically anything we have in JavaScript. Here's a couple more. I just went demo crazy on this part because I think it's so cool. Let's see here. So I think I alluded to earlier, this gives us the ability to basically take advantage of any of the existing like JavaScript visualization libraries. There's one called Anime.js, for example, that does animated images and timelined animations. This was another advent of code problem. If you remember the sort of towers of Hanoi Day from advent of code. The visualization for that. So this is a JavaScript library. Let's scroll down here. Let's see here. Where is my anime.js? There we go. Right. So all the code for what you're seeing on screen right now is Python, but it's hooking into the anime.js library to make it happen. And this is really cool because I was like, oh, look at that cool JavaScript thing. Or you can do what in JavaScript? I'm so sorry. Now we can write it all in Python. Right. So we're treating, for example, the anime package, so we can import it from JavaScript. This has a Python object. We can call it, we can pass it keyword arguments, we can put it into partial, like a document partial. It's just a Python object that's in proxy. So there's some of the coolest stuff that we're doing is coming out of this. Another one, just to steal one more demo, is from 3.js, which is a visualization library, doing some fun like classifications running around. Again, all of this code is written in Python, right? So all of the pick a random number for when this particle should appear and disappear. And, I don't know, honestly, I don't know how randoms work in JavaScript, but I know they work in Python. So you can write your code in Python and just hook it into JavaScript. Yeah? It's cool. It's cool. And so you start looking around like, oh, what other weird JavaScript demos are there out there? What other libraries have we got to play with? How can you use Python? All right. Questions? Yeah.
So is it able to do that graphic stuff mainly because it uses WebAssembly?
No. Good question. The question was, can it do the graphic intensive stuff because it's WebAssembly? And the short answer is no. The Python that's running there, that's triggering it, is running that code in JavaScript, essentially. We'll talk about performance here in a little bit. There are definitely some performance penalties to running in the browser, and not necessarily WebAssembly, but in the browser versus on your desktop. But for the accelerated stuff, hooking that into the JavaScript side or running it in pure WebAssembly would be faster. Is there a question there?
So everything PyScript we transfer into JavaScript, and that's what we run through the browser.
Not exactly. So the CPython interpreter is being translated into WebAssembly and is running there as a C program. The PyScript source code is written in TypeScript, right, which is compiled to JavaScript, and that's what's controlling the user interface. All of the elements that are creating the PyScript tag, the custom PyScript tag, the custom PyRepo tag, that's all JavaScript, right? So the interface elements are written in JavaScript because that's what the browser knows, but the code is running in WebAssembly. And then for stuff like interacting with an external library, that's just hooking to some JavaScript that's already there. That sort of makes sense? I feel like I said the word JavaScript a bunch, and maybe it's but yeah.
So with the package loading you mentioned, so let's say you want to have an immutable build where you just have all of your packages present, locally or something, and you don't. Is there a way or a strategy to get it so you might install a package that installs a bunch of downstream dependencies. And assuming they're all Python based or Python plus the 150 supported
Yeah.
ones, like, is there a way to like bundle that up so you don't, or do you have to fish out each wheel?
The way I would approach the question was like, if you have a bunch of pure Python packages, they're all depending on each other, and you want to just like basically make sure that my app is frozen, right? I want to download them all at once when the page loads. There is some functionality in PyDI for basically unmarshalling or unzipping a set of files and installing them as one, right? So probably what I would do is take that set of packages, download the wheels, zip them, and then in my loading step, I would say, as part of load, unmarshal this whole package and install that. It's probably the most convenient way. Yeah.
Which one is faster?
Faster between which?
Between like, does anybody benchmark like, this is a place to be doing like Python, CPython and like PyPy or something?
Yeah. So the question was like, what's faster? Like, what is the performance penalty for running in the browser?
Or if there is.
Yeah. Well, so the short answer is there is. Just because unless there is some busted build of Chrome you might not know about, your browser window is not going to have, by definition, as much RAM as your computer is, or full access to your processor speed. There have been some comparisons done by the team on as close as we can figure, like comparing numerical calculation between JavaScript and Python running in PyScript. And the numbers come out kind of all over the place, depending on exactly what you're asking to do. I would say it's on the order of a 5 to 20 times slowdown for a basic action, but it really depends what you're doing. I don't think anyone's benchmarked, like, I don't know how that benchmark stacks up to JavaScript versus CPython.
Yeah, they have like a Jupyter Hub Lite. Low to low, but it seems perform at that.
Yeah. The biggest penalty, I think, is the page load, right? You have to download a bundle of between 3 and 50 megabytes before anything starts. And once that starts, that's great. And especially if you're using a build system that keeps your library sort of, your JavaScript or your WebAssembly maintained between page loads, like if you're building in Vite and sort of jumping between pages isn't really jumping between pages, it's just refreshing the UI. So you don't have to load TypeScript every time, that's great. If you have a setup where you have to load 50 megabytes every time a page loads, that's rough. I'm not gonna lie, that's a huge penalty. One of the cool things that's coming out, I don't have a slide on this, but we'll just be here together. One of the cool things that's happening is looking at shipping just the compiled standard lib to the browser instead of the full standard lib, right? So right now, PyDI bundles most of the standard library to the browser, where it's executed there. You would save about 30% if you just sent the .pyc file, that's the compiled version of the Python. But then your tracebacks don't mean anything because you have an error. And it says I have an error in standard, in curses line 461 that I don't have access to. Right? So there's some trade-offs in terms of like legibility versus download size that are kind of interesting. That was a tangent.
I'd like your side.
Yeah. Other questions? Yeah.
Is there any sort of time in TypeScript to work with PyDI to let the user opt in instead of caching the Python working locally so that every time they make a page, they're not pulling the whole standard library?
Definitely, yeah. So I should say by default, right? It's a JavaScript and Blossom bundle. Your browser will probably cache that part, which is good, right? There is also a step of initializing the WebAssembly into the page that is also slow. Not slow, but on the order of a second or two for a desktop browser. That's that spinner that we saw earlier. And making that faster is just a process of like optimizing the WebAssembly, which is like honestly beyond me. But the caching does help a great deal for sure. Yeah.
You talked about how to get local files into this environment.
Yeah.
Is there any way to get around the common language or
the cores?
The standard when you download a package, it's got to come from where the website came from. Common origin.
Yeah. So yeah, questions about common origin resource sharing policies. That is more. So one thing that can happen for those who haven't touched web in a while. I know you have. We were talking about it after the last interview, and you're deep in it. one thing that can happen is if you're trying to download a piece of JavaScript from a different place than the server that originated the web page, most browsers will say, this is probably malicious, maybe you shouldn't do that. It is more a property of server permissions. The PyPI servers, or mirrors, I should say, that we're hitting, and the PyDev servers are cores open, right? So they're saying, make requests to me, I will serve them back to you, it's fine. We more actually see it with users who are developing locally, but pulling PyDev remotely, and they try and pull a local file into that, and it says, this local file is not from the internet, I will not load this. So the solution there is to run a simple server locally, which you can do via Python, or your live server in VS Code or what have you. But that's mostly where we see it. It's more of a server-side issue than a PyScript issue, if that makes sense. It's not something I will say that you run into just when you're trying to fetch these files from various places like Python and PyPI. They're all massive. Yeah.
Are there any peculiarities between different web browsers, so between mobile, Android platforms, web browsers versus a desktop?
Yeah, so there's not really, in terms of the WebAssembly spec and the CPython runtime actually running, the differences are minimal. And that's probably because the WebAssembly standard is really well written and really well implemented across basically all major browsers now. There are differences in limitation in sort of in the JavaScript side, right, in terms of what browsers will allow. But in terms of the functionality on mobile versus desktop, other than like available resources and bandwidth, not really is the cool answer. Yeah, and this is one thing when I publish it, like having a code page, I go and like see if it runs on my phone and just be like, ooh, this is like an algorithm that takes like a second on my desktop is now taking like 20 seconds on my phone just because it's not throwing enough resources at it. So, well, that's not so good. But the capabilities are there. Cool. Those questions? How are we on time? Am I going way over?
You're good. Whenever.
Awesome. Well, then we'll get to this. My planned tradition was we'll get to the nerdy part, but here we are. We've been there all the time. I want to talk about the stuff that makes this hard. Makes it hard to run Python in the browser and in this sort of sandbox environment under WebAssembly and various things. The big one is you get one thread. If a browser window is one thread, for lack of a better term. And this is something that's been worked on in many ways in the JavaScript ecosystem for years, but you don't get a second thread to handle additional I/O. You don't get the multi-processing library that we love in Python to like spin off strange things. You don't get sub-process, right? You have one thread. And if you block it, everything's done. If you've ever had a situation where your Chrome window like goes to the little sad face and then everything is actually to kill it, right? Probably happened some JavaScript or some PyScript. It has entered like a while true loop, and there is no way to break that because there is no other thread to come in and send that break message to the first thread. Chrome, as sort of the spawner of that thread, has permission to go in and kill it. But from within the CPython environment, certainly there's no way to spawn additional thread. Cooperative multitasking, so async.io and its friends do work. Spawning a new thread is a no. Defining coroutines and running them actually works great. For those who are async.io nerds, the coroutines in Python actually get scheduled into the browser's event loop. So they run in the same way that an async await function works in JavaScript. You can actually await a Python function from the JavaScript side, which is cool. They work slightly differently, so you shouldn't, but you can. But this is a significant limitation, right? We'd like to spawn additional threads to do hard work, especially for some of the data sciencey stuff that we'd like people to do with this. We'd like to have additional threads. There is hope. Someone mentioned service workers earlier. Was that you? Yeah. So service workers and web workers are probably going to be our solution for this. A web worker is a newish API that allows you to spawn a subsidiary thread associated to your browser window. Awesome, we can do stuff with that. It is a pretty limited thread in that it doesn't have access to the content of your page. It doesn't have access to the events happening on that page. It doesn't have access to the global scope of that page. So you basically need to do message passing between your main thread and these subsidiary threads that you spawn, right? Which is not that different from how you have to deal with threads in Python, right? If you've ever gone down the rabbit hole of like, okay, I'm going to spawn a thread and pass it okay, it's a mutable argument. Oh no, same kind of thing. right? So what we would like to do is run our Python code in a web worker, right, where it's not blocking our main thread and sends signals back to the main thread. Service workers are on here actually because they do allow blocking I/O. You can use a web worker to simulate a while true loop in the main thread that you can exit out of for reasons of your file download might be synchronous. So JavaScript in this one case says, I will let you do this synchronous thing and then come back to the main thread. So, but other than that, we're sort of stuck in this world where we want to do one thing at a time. And from an end user point of view, right, if you were to go home tonight and type in those tags and do a while true, your window crashes. And there's no control C, right? Break doesn't work. There's no additional thread to throw that control to throw the break, right? Which is bad UI. So we're working on it. Performance, we talked a little bit earlier, it's just never going to be, it's never going to be quite as fast as desktop Python or JavaScript with the limitations. Also, the JavaScript runtime is already loaded onto your computer when you download Chromium, right? We have to load our runtime when the page loads, right? And from a UX perspective, that's not ideal. We talked a bunch about packaging tonight already, so this slide's a little redundant. Those are the things you can install, your pure Python packages, your packages from PyDI, user-built wheels if you're building them yourself. Versioning is hard though. Oh man, versioning sucks. So if you're compiling all of these Python packages and their C extensions to work together, you basically have now sort of one consistent version of them that does work together. Like if you have holders that relies on NumPy, you need to make sure not that only that both of them compile, but that their C API is compiled in a similar way. So basically, each major version of PyDI ships one version of each of those packages, which means they work together. But if you have a separate app that relies on the last version of NumPy to work, it's not guaranteed to be compatible, right? And the PyDI folks, which is also an open source project, don't want to become another package authority if they can help it, right? That's a job that never ends. But there's some improvements there too in terms of maintaining delivery and compatibility. Other things that are hard, JavaScript and Python don't agree on some fundamental ways you should use them, right? Like if you have this tag, this will run in your browser, right? You took some code, it's a Python file, you put 2 script tags, you run it, it'll run just fine. What's the equivalent of this in desktop Python? Should this be the equivalent of importing that module twice? It's kind of what it feels like, except if you import it twice, it's already cached, so it's not going to import again. Probably what we want to do is run that code twice. But if we have code that's not associated to a module when it runs, what is it? There's like little weird that you compile things like this. Similarly, because source is a URL, if you've ever had to use something that relies on the file attribute, that's for global file object when you run Python, it tells you what file you load it from. What should the file be in this URL example? What should we set that to? What's a good default that lets things that are supposed to just run with files work? Right? So these are some of like the weird hard problems that don't have good answers. If you think you have a good answer, come to the GitHub and contribute. We talked about other stuff you can't do in the browser. Blocking input, again, is hard. You can't launch other programs. You can't launch idle within your browser, right? You can't make blocking network requests. The requests module is broken by the fact that if you have a network request that is blocking, or that waits for a response before it responds, the JavaScript main thread blocks. And now, again, we can't do anything because we have one main thread. There are some shims for this, actually. There's some cool progress that basically lets you say, import other library as requests. Most of your other code will just work. This is a hard problem. And this is just a little list of like the packages in standard lib that don't work for all the reasons we talked about. So threading, multiprocessing, sockets. There are sockets you can access in the browser. They don't work like desktop sockets, so there's some like sort of adapting you have to do there. Curses, the terminal library. We don't have a literal terminal in the browser. That one's hard. tkinter and turtle both like reach into the operating system's UI and drag out the window for themselves. We're not doing that within a browser. Virtual end, we have a different system of creating and loading packages, and idle, again, it's just like, it's doing such low-level stuff at the operating system level that just doesn't work in a browser window. All right, last slide. What's next? What's the cool stuff? We're adding more runtimes. MicroPython's the big one, but others are coming. Moving toward web workers for better UI. Adding this plugins architecture so you can extend sort of functionality for your users. Scopes tags. Okay, 30 seconds on scopes tags. So in JavaScript, everything is global. Everything is global. I mean, yes, there are objects, and yes, there are namespaces and all these things, but by default, stuff in a script tag is in a global namespace. And we have a lot of people in our team and in the Python ecosystem who are used to saying, if it's in a module, it's in that module's namespace. It should stay there and not touch any other of our code. So we're trying to find what is the UI appropriate way to incorporate that idea into a world where all of our variables were by default are global currently. So weird UX problem. It's either gonna make the Python people mad or the JavaScript people mad. Documentation, tutorials, all this stuff. If this is like, oh, that's cool, I wonder if I can contribute. Documentation is always a great place to start. There's no better way to learn a library than trying to explain it to somebody else. A lot of cool stuff coming up. One final time. Questions? Ooh, a bunch. Let's go around there. Yes, sir.
So I'm guessing if you throw an exception, it's only have one thread. It'll kill the page still.
No, actually, exceptions work great because exceptions basically kill your interpreter. So let's see here. What's everyone's favorite exception?
Base exception.
Oh, I guess I could raise a base exception. How about
One
how about a
divided by
division
zero.
by
Yeah.
zero? How's that? That's an easy one. So it actually just gets printed to the page. We get a trace back. We get exact in line 1 division by 0 error. Right. So exceptions work fine because it basically is not blocking anything. It's just giving up and running the code.
Oh, so strong code.
Yeah, exactly. Yeah. Fair question though. Yeah, going around. Yeah.
So if I or anybody else wanted to pick up tickets and work on PyScript, do you have like the easy ticket tag or good first issue ticket tag? Do you have a contribution guideline page?
We do. Yeah. So yeah, we have a thank you, Wheeler, for asking. We do have a good first tickets tag on our GitHub. We do have a contributing guide. The contributing guide, I actually will say, is really quite good and walks you through the build process for PyScript is not hard, but there are a few steps to follow. You clone it from GitHub, you download some npm packages, and you build it using a makefile. So it's a lot easier on a POSIX system than it is on Windows. You can do it on Windows, it's certainly possible. But yeah, we would love to see people come pick up some of those easy tickets or some hard tickets. Really awesome. Great question. Yes, sir.
So you see this replacing Django and other web frameworks like classic Python applications, web applications?
Potentially, I wouldn't say replacing, but I would say that there's going to be some applications where you want to bring the Python closer to the user, that this makes more sense than something heavyweight like Django. It's funny you should say one of the folks at Anaconda just gave a talk at FOSDEM this weekend called "Will PyScript Replace Django?" And she says it more eloquently than I will. If you're looking to do something that runs Python code, TypeScript or Python is a good way to go. If you're looking for something that handles things like routing natively, like a framework that already has that built in might be easier. Yeah.
Yeah, how does this compare with what they're doing in Jupyter Lab in the browser?
Yeah, it's a good question. So in comparison to like Jupyter Lab stuff and other ways you can put Python in front of the user, there is actually a distribution now called Jupyter Lite, which is meant to be a Jupyter Lab like interface, but also running in the browser, which also uses Python. Right, so exact same context. Like a lot of people are, I should say, like we're excited about this. I'm excited about this. This is a thing that a lot of people have gotten onto is that like web is accessible and Python is good, and so there's lots of cool progress in this space. So yeah, if you like Jupyter Lab as a concept and you want to run that in the browser, Jupyter Lite is the search term for sure. The capabilities in terms of the runtime is pretty.
But you can just do PyScript.
You can just do PyScript. Yeah, certainly be happy to. Sometimes we get people like using PyScript when maybe they should just use Iodide. It's like, I want to run this JavaScript function that runs some Python. It's like, well, if you want to just reach in and run some Python and not do any of the sort of display and UI stuff and easy to use stuff, you can just reach in and use Iodide as a CPython runtime and bypass us, right? But if you want sort of like an on-roading thing, PyScript is the way to go. Yeah.
Do you like? Is there a cryptography library that's supported in?
There is, I think. I know it's on the list of Python supported. Just crypto, I think the crypto module is supported now. And this brings up a good point because this is a question we get a lot: is how do I make an API call from something like this, and how to make it with credentials in a safe way? The answer is you don't, because everything lives in the client, right? It's a client-side library. Anything the client can use, the client can see. So there are some schemes, right, where you say you set up with a service only, make a query to my middleman endpoint only hand you an API key back when it comes from this server I designate. But if you put your API key into your PyScript code, it's getting sent to the client, and then the client tests it, right? Now, that's been true in JavaScript for ages. It's also true here. Yeah.
Can it still back query the SQL query back on the database server on the like your web server, whatever back?
For sure. Yes, you can make database queries if you have them on your server, especially if you have like an HTTP server in front of your database. Yeah, you can for sure make queries. Yeah. This is an area where it's like I probably would hook into JavaScript to do that. We probably need a Python API in front of that to just make it more clean. The JavaScript APIs for like DOM manipulation and data manipulation feel very JavaScripty, and they don't feel very Python-y. This is another like element of development. It's like how do we make interacting with the page feel like Python instead of feel like how you would do it in JavaScript? And same thing with like database access. It feels like we are just using JavaScript. We'd like to have us run Python if we can do it. Yeah. Yes, sir?
You said that Turtle and Enter aren't supported in PyIodine. With your ability to do web output, it would seem like you could port these to the PyScript side.
Yeah, so the point was like, could we take some of these existing UI libraries like tkinter, or maybe like PyQt is one we see mentioned a lot, like existing desktop UI libraries, could we put them in the browser? And it certainly would be possible. The amount that you would, from what I understand, because I haven't tried, the amount you would need to shim in terms of like creating the idea of a repositionable window in a browser that interacts the same way that an OS window does, it would be significant. What we're actually seeing more of is people adapting web UI libraries to use PyScript and PyDive. So just this morning through the Discord came somebody who has built a package called, I think it's called Flet, which allows you to write Flutter apps that integrate with PyDive. So if you know the Flutter UI library, you can basically port that over into PyScript directly. Another called HTag, which is like a different HTML manipulation library. So it's certainly possible. And if you'd like to volunteer, bonus questions? Yes, sir?
It's more theoretical question about the traction of all these things and what problems you worry about. Just like the law of understanding of certain things, the abstraction and definition is necessary for this browser and stuff like that. It's just my experience. Like from other things, from other factors, you just lost information completely and don't understand certain things. Not just computer science in general. But I understand the point technology is advanced on top of something that
For sure. Yeah, so in terms of like loss of knowledge with like putting all this stuff on the web and like making it, there's this tension, right? Like the easier it is to access, the more people will get to step A. Does that mean they didn't need to learn steps A-1, A-2, A-3 to get there? Yeah. If there is some underlying knowledge that people will need to gain along the way. But I think there's also value in saying, I can put a REPL on my static site right now, right? And that's cool. And let anyone run Python in their browser or put Python on their website right now. That the ease of access, I think, sort of outweighs some of that loss of knowledge, but that's just me. That's just mine. I think I've taken about as much of your time of being a huge nerd here. If you have more questions, I'm gonna hang out here afterward. We can keep chatting. Slides are at dev.glass/chippy. Come find me afterward or any of the places. And thank you so much for your time.
All right, that was Chippy. The after party is next door in the bar. And she's got the first round. In addition to your drink tickets, I guess. Or drinks. Yes, it is. Oh, good.